Hello everyone, my name is Shivakali Narendran and my matrix ID is TA22048. Today I'll be talking about half-wave rectifier and full-wave rectifier regarding my electrical fundamentals assignment. First of all, I'll be talking about half-wave rectifier for AC wave. From the graph can we see here, we can conclude that the input voltage is a sine waveform which shows the frequency of 60, period of 16.6, VPP 339, Vmax is 169 and Vmean is negative 169. VRMS is 119, rise time and fall time is 4.94. According to the graph, the volt is 100 voltage and the time is 20 ms. There's an alternating voltage which is 1K produced from the input voltage. Any voltage that changes in magnitude and polarity over the time is considered to be the alternating voltage. Next, I'll be talking about half-wave rectifier for DC wave. The frequency is 60, period is 16.6, VPP is 168, Vmax is 168 as well, Vmean is negative 5.07, VRMS is 65.1, rise time is 2.73 and fall time is 2.64. The term half-wave rectifier refers to a particular kind of rectifier that only permits one half cycle of an AC voltage waveform to pass while blocking the other half cycle. To convert AC voltage to DC voltage, half-wave rectifiers are employed. They can be built with just one diode. As a result, as seen in the image, the output waveform lacks a negative cycle. Low voltage produced using half-wave rectifiers. This demonstrates how diodes only let one direction of current flow. The diode is connected to produce a positive half cycle with a forward bias. Wherever else, the diode should be connected in reverse bias during the negative half cycle. The voltage output from the half-wave rectifiers is equal to the input voltage. Moving on to the next part is full-wave rectifier for the AC wave. From the shown graph, we can conclude that input voltage is a sine waveform which shows the frequency of 60, period 16.6, VPP 239, Vmax is 119, Vmean is negative 119, VRMS is 84.8, rise time and fall time is 4.94. According to the above graph, the volt is 50 voltage and the time is 2 ms. There is an alternating voltage which is 10K produced from the input voltage. Any voltage that changes in magnitude and polarity over the time is considered to be the alternating voltage. As for the full wave rectifier for the DC wave, the frequency is 120, period is 8.33, VPP is 118, Vmax is 118, Vmean is 479, VRMS is 36.9, rise time is 2.71 and fall time is 2.72. A full wave rectifier is a particular kind of rectifier that creates a pulsing DC signal by converting both halves of each cycle of an alternating wave AC signal. Multiple diodes are needed to build full wave rectifiers, which converts AC electricity to DC voltage. The technique of converting an AC signal to a DC signal is known as full wave rectification. As a result, the output waveform demonstrates that the AC voltage's negative cycle has been transformed into its positive cycle. As with the AC input voltage, the voltage is the same. As a result, a constant DC voltage is produced with no losses. High voltage is produced by full wave rectifiers. 4 diodes are present in full wave bridge rectifiers. There are 2 diodes connected in reverse bias and 2 diodes connected in the forward bias, because we are rectifying both the positive and negative sides of the waveform where the frequency is doubled. So this is the full wave rectifiers for AC and DC wave. So finally, for my conclusion, I would state that a rectifier is an electrical component that converts AC current to DC current. A rectifier is analogous to one wave valve that allows an electrical current to flow in only one direction. The process of converting AC current to DC current is known as rectification. A rectifier can take several physical forms such as solid-state diodes, vacuum tube diodes, mercury arc valves, silicon control rectifiers, and various other silicon-based semiconductor switches. As per I explained before, there are 2 types of rectifiers, which is half-wave rectifier and full-wave rectifier. Full wave rectifiers require numerous diodes, while half wave rectifier just need one. In contrast to full wave rectifier, which rectify both positive and negative cycle of AC, half wave rectifier only rectify one cycle of AC. In a half wave rectifier, the current through the load is not continuous, but in a full wave rectifier, the current through load is continuously flowing opposite to the half wave rectifier. In comparison to half wave rectifiers, full wave rectifiers are more effective compared to the half wave. Full wave rectifiers have superior voltage regulation than half wave rectifiers. Half wave rectifiers are less expensive since they only need one diode, but full wave are more expensive because they are in need for more diodes. So this is my half wave rectifier and full wave rectifier project conclusion. Thank you so much, everyone.